Hello students, let us continue our discussion on the various laws. Avogadros law is a very important law which we need to understand. Now what does the law state? It states that if you take equal volumes of gases under same temperature and pressure, then the number of particles contained in all the gases will be same. So here you can see we have drawn a schematic diagram. I have taken different jars and I have labeled the gases as A, B, C, D. Now what is common in all of them is volume XCC. You can check all of them, they have same volume X. Now if I take the temperature and pressure same, then the number of particles in all of them also will be same, that is I have written here Y. Now in case you take X to be 22.4 liters and you take standard temperature and pressure, then the number of particle Y will be invariably 6.023 into 10 to the power 23 particles. 10 to the power 23 particles is a very big number, okay, and this particular number is called Avogadros number. So that is what we understand by Avogadros law. So what is common in all of them? What is the condition to apply Avogadros law? The volumes of the gases has to be same. Temperature and pressure of the gases also should be same. As you know, volume of a gas is very much dependent on temperature and pressure. So if the temperature and pressure are not same, then the volumes are going to be affected, and as a result the number of particles also will be affected. Next we move to the next law, that is Gails law. Now Gails law is strictly applicable for gases and the volumes of gases. So what does the law state? It states that when gases react, then the ratio of the volumes of the gases will be always a simple whole number ratio. And in case the product formed is also a gas, then the ratio will be extended to the product as well. So here I have taken an example of water. Water is formed from hydrogen and oxygen, and if the temperature is more than 100 degrees Celsius, then the product formed is also going to be gas. Otherwise, if it is below 100 degrees Celsius, the water will be liquid. As you know, boiling point of water is 100 degrees Celsius. So the ratio of the volume of hydrogen, oxygen and water will be the coefficients which we use in the balanced equation, 2:1:2, as you can see here. Okay. That means if you take 2 liters of hydrogen, it will combine with 1 liter of oxygen to produce 2 liters of water vapor, not liquid water. Similarly, another example we take, when nitrogen in the gaseous state combines with hydrogen in the gaseous state, it forms ammonia. These reactions are very well known reactions. Now to balance the equation, you can see here we need 3 molecules of hydrogen and 2 molecules of ammonia to combine with 1 molecule of nitrogen. So the coefficients of nitrogen, hydrogen and ammonia are 1:3:2. That means if you take the ratio of the volumes of nitrogen, hydrogen and ammonia, they will be 1:3:2, which means if you take 1 liter of nitrogen, it requires 3 liters of hydrogen to combine to form 2 liters of ammonia. So if you know for any other volume of nitrogen, you will be able to calculate accordingly. Next we have Dalton's atomic theory, which you have learned in class 9 or 10, I think. So I have marked it as self-study. Please go through the postulates of Dalton's atomic theory on your own. Next comes atomic mass. Now atomic mass, how we define? Earlier we used to say that atomic mass is nothing but the number of protons and neutrons in the nucleus of an atom. But otherwise how we define? Because some of the atomic masses will find that we are considering them in fraction also. So atomic mass is measured with respect to hydrogen atom. How many times an atom of an element is heavier than one hydrogen atom? Yes. So it is just like as if you are going to a grocer's shop and you are asking for say 5 kgs of rice. Now how does the grocer give you? He places the stone of 5 kg in one pan and accordingly he places rice or sugar, whatever you are buying, on the other pan. When the pointer is exactly at the center, neither tilted this side nor that side, then you know that that much of sugar or rice is equivalent to 5 kg. Similarly, in chemistry, the stone is equivalent to hydrogen. So if I want to know mass of one carbon atom, so what do? We place one carbon atom on one side of the pan, which is practically not possible. Let us just assume. Then we keep on putting hydrogen this side till it gets balanced. Okay. So it has been found that if you put 12 hydrogen atoms, then it equates one carbon atom. That means one carbon atom is 12 times heavier than one hydrogen atom. So how we define atomic mass? Now you see, it's very difficult to deal with hydrogen. First of all, it is very light, and secondly, it is a gas. So if you go to a grocer's shop and ask for 100 kgs of rice, he has options. He may place 100 stones of 1 kg on one side of the pan, and then he keep on measuring rice, or he can put 10 stones of 10 kg each and keep on measuring rice on the other pan. Both will give you equal quantity of rice. But which way is convenient for the grocer? Definitely putting 100 stones of 1 kg is more difficult than putting 10 stones of 10 kgs. So exactly the same way, instead of taking hydrogen as the reference, now we take carbon as the reference. So before I go to the definition, let us try to see here. We know that 12 hydrogen atoms is equivalent to 1 carbon. Therefore, 1 hydrogen is equivalent to 1/12 of a carbon. So in the definition, what it states? Atomic mass of an element is the number of times an atom of that element is heavier than 1/12 the mass of a carbon 12 isotope. So from where we get this 1/12? This 1/12 we get from here. Okay, this 1/12 the mass of carbon atom is same as 1 atom of hydrogen. So that's how we define atomic mass. And the unit of atomic mass is AMU, that is atomic mass unit. And nowadays, of course, atomic mass unit is also not used. We write unified mass unit, and the symbol for unified mass unit is just E. Next comes molecular mass. The definition of molecular mass is not properly given in your book. What is given in your book is how to calculate molecular mass. So molecular mass is very similar to atomic mass. Just replace the word atom by molecule and atoms and element by, of course, it can be element or compound. Molecular mass of a substance, it may be element or compound, is defined as the number of times the molecule of the substance is heavier than 1/12 the mass of carbon 12 isotope. So it is very similar to the atomic mass. Here also the reference stone is carbon 12 itself. So calculate the molecular mass of hydrogen. So if we want to calculate molecular mass of hydrogen, which is an element, so hydrogen is an element, and we know hydrogen is a diatomic molecule. 2 atoms of hydrogen makes 1 molecule. So here we write number 2 to indicate the number of atoms and multiply by 1, which is the mass of hydrogen. So the answer will be 2 unit. Similarly, oxygen. There are 2 oxygens make a molecule. So 2, atomic mass of oxygen is 16. So 2 into 16 makes it 32. Then we have water. You can see there are some star marks given. Why did I put star mark? Because they are very frequently used molecules and their molecular masses are very often needed. So instead of calculating every time, you can try to remember them. So there are 2 hydrogens in water. So I have written 2 into 1, and there is 1 oxygen. So 1 into 16. They are added, and the answer is 18 units. So please remember, molecular mass of water is 18 units. Similarly, carbon dioxide. There is 1 carbon atom, so 1 multiplied by atomic mass of carbon, that is 12. Then there are 2 oxygen atoms, so 2, and multiplied by atomic mass of oxygen, that is 16. So it is 12 plus 32 makes it 44 units. Similarly for ammonia. Alright. There is a table in your textbook at the back, appendix 2 most probably, where you will find the atomic masses of all the elements of the periodic table in alphabetical order. So please refer to that table when I have given you some homework. You can try calculating the atomic mass, molecular masses of these many molecules. Now I request you to take down the definition of formula mass from the textbook and also write down the definition of average atomic mass from the textbook. So once you write down the definition of average atomic mass from textbook, here we have the formula by which we can calculate the average atomic mass. So average atomic mass of a element, usually when you know that elements are present in isotopic form, then the mass which we calculate is average atomic mass. So average atomic mass is equal to summation Na divided by summation n. This symbol summation means adding up. Okay. Now this means N1 plus A1. That means if you have two different isotopes, say hydrogen has three isotopes, hydrogen 1, hydrogen 2 and hydrogen 3. So N1 into A1 plus N2 into A2 plus N3 keeps on going, divided by total number of particles N1 plus N2 in the present case. So what is N? N stands for percentage or fractional abundance of a substance, or it may be in terms of ratio also, and A is the isotopic mass. So let us try to understand this with the help of an example. So chlorine has two isotopes, chlorine 35 and chlorine 37, in the ratio 3:1. Find the average atomic mass of chlorine. So let us write A1, that is atomic mass of chlorine is 35 units and its ratio is 3. So N1 is 3. Then A2 will be 37 and N2 will be 1. Now put it in the formula N1A1 plus N2A2 divided by N1 plus N2. So if you put the values here, the total comes to be, the average atomic mass comes to be 35.5. Now I have given you one homework. Fractional abundances of neon 20, neon 21 and neon 22 are given. Okay, find the average atomic mass of neon. So your A values are here. This is A1, this is A2 and this is A3. This is your N1, this is your N2 and this is your N3. Now since it is given fractional abundance, so please remember fractional abundance, when it is given, sum total of N1 plus N2 plus N3 will be 1. If it is given percentage abundance, then the sum total in the denominator, that is N1 plus N2 etc. values will be 100. So please work it out. I have given you the the answer also. Please check whether you get this answer. And then you have some questions in your textbook. Exercise question 1.9 and 1.32, and please try to solve them. And you need calculator to work it out. So please complete the work. Thank you.